very special kind of change, and that's translations. So what do we mean when we say translation? What's a translation? That's a translation. A translation simply means to move along a direction. Now, you can take tiny steps, so you can have small translations, or I can take big, long steps and have big translations. Translations are simply straight line motions. And so, that's what translations are. They're motions along a line. At the most primitive level, this will suffice for definition. Now let's see what this actually does for us. Suppose that we have some function of x. Then, what does it mean to translate this function by a meters? Well, if the initial location, I'm going to use the symbol t for translation. That means the act of making something translate. So suppose I want to translate the field through a distance a, what does that actually do to the function? Well, if the original function is at position x and you translate the x-axis by the number a, then the function must be evaluated at x plus a. That's what we mean by a translation. You took the measuring line and you translate it, right? Simple definition of translation. Now that we know what a translation is, let's talk about a very special class of translations. Suppose that we look at translations that are infinitesimal. Now, what does that mean to say that the translation is infinitesimal? It's a statement about the size of this number, right? If you say that something is moved infinitesimally, you're saying that this thing is something that is incredibly small. Maybe it's 1 over 10 billion, or 1 over 10 to the 10 power, or 10 to the 110 power. It's a very small number. Now, if a is very small, but we'll consider it positive for the moment, for simplicity's sake. If a is small but positive, then there's a very famous theorem here that tells us how to evaluate this. What would that be? Taylor's theorem. Taylor's theorem tells you how to write something as an expansion in this parameter. So under a translation, under an infinitesimal translation, and now I'm going to change notation on you, I'm going to write this as delta t of a. And the t means it started out as a translation, but now because I'm making it an infinitesimal translation, it makes a change occur. And so delta t of a of f means take this thing and use Taylor's theorem. Well, that gives us, Taylor's theorem says if you expand about a, the leading term occurs at a equals 0, then there's a term that is proportional to a times the derivative of f of x, I'm sorry, I'm using straight derivatives here, evaluated at a equal to 0, right? And now, because a is an infinitesimal, I stop this entire series. That's the end of the series. Because for an infinitesimal quantity, part of the definition of an infinitesimal is that when you square it, you get 0. And the next term in this Taylor series is a squared. So now I have figured out what the infinitesimal change of a function is. The infinitesimal translation of a function is just a, whoops, I'm sorry. I'm sorry, let me try this again. I made a terrible error here. Let's straighten this up. What I really want is the following, to note that, that t of a, let me write it like this, a delta of t of a, of f of x, is just this leading term. That's the change. The change means you look at the thing how the function changes from what it used to be. So you have to subtract off the leading term in the Taylor series. So it's just this.